So, our next segment is about why is a negative number times a negative number a positive number? And what we saw when we were adding and subtracting integers, when we thought about subtraction as take away, it helped us to really understand why removing negatives helped make the total more positive, right? So subtracting a negative by taking away that negative, that's was the same as adding a positive, right? Making the number, the total, more positive. But if we think about the interpretations of multiplication, right, we can think about multiplication as repeated addition, right? Repeated addition. We can think about it even as skip counting. We remember skip counting. Sorry, and I know this is terrible. Repeated addition, skip counting, repeated addition. We can think about it as equal groups. And as an array or the area. So if these are our ways of thinking about multiplication, well, how do we explain this idea of a negative times a negative as a positive? Because if we're thinking of skip counting, we could skip count negatives and count down like -3, -6, -9, -12. That works, but I can't count negatives, or I can't do a negative count, right? Because still -3, -6, -9, -12, right, would still be this kind of idea of, right, 4 groups of -3, or right, -3 4 times. And so we still have a positive for the number of groups, right? So this is right why -3 times a +4 would be that -12. And that's exactly the same for this idea of repeated addition, right? A -3 plus a -3 plus a -3 plus a -3, right? We keep adding more negatives. And again, that makes sense why it's getting more negative, right? Keep adding these negatives. Sorry, that's getting crowded in there. Sorry, and maybe I'll use a different color. Um, and then likewise, right, this idea of equal groups, right? We would have a positive number of groups. To have a negative number of groups, can you have a -4 groups of -3, right? To have a negative number of groups doesn't make a lot of sense. Um, oh, and these should be negatives. Um, so, oops. So these are the things I want you thinking about when we're trying to explain ideas. And if you're kind of stuck, you're not alone. And this is another reason why negatives are difficult for humans to really conceptualize, because while we can think about adding and subtracting positive and negative numbers, right, we have real life situations in which we do that, right? We add negatives, right? You add ice cubes to a drink and you're bringing down the temperature, right, of the drink, or your glass of water. You can think about losing money, right? A debt, or debits. If you're taking away debits, then you're adding to your total overall. But this idea of a negative times a negative, right? Negative amounts um, is tricky, because I don't think that there's a real life like explanation or like example of this idea. And so this is where, when we get into this kind of abstract mathematics, it's hard to conceptualize, because now this debate between, is math discovered or invented? Well, if we discovered these, or if we say we invented these negative numbers, well, now we're discovering their consequences, because they're going to behave in ways that we don't really have an analogous or like real life example of what that exactly means. And so what we can do, though, is use mathematics and reasoning to explain how and why this happens. So let's just start with some friendly numbers, like the number 2 times 3, right? We know that that's a +6. So but now I want to take away right, minus a 2 times 3. And that's going to give me 0, right? And so this is the same as if I added a negative 2 times 3, right? Right? Because we talked about this idea, or we could say it as a negative, I don't know which way you like better, the 2 times 3 plus 2 times a negative 3, right? Whichever you like better. And this is all still going to be 0. If you wanted the 2 negative or the 3 negative, I was just maybe thinking to keep the 3 negative like our original example here, right? So this kind of negative 3 to negative 6, right, would be this 2 groups of negative 3. And then, so if that's the case, if 2 times 3 plus 2 times a negative 3 equals 0, well, another way to explain negatives, and this is the only definition of this word in mathematics, is to think about it as the opposite, right? So the opposite of 3 is negative 3. The opposite of 2 is negative 2. And so, so if a number is negative, it's also known as the opposite. And now if we think about, well, if I wanted to, if I subtracted this 2 times a negative 3 from both sides of this equation, right, to keep it all equal and balanced, then I would get this positive 2 times positive 3 is the same as, right, 0 plus or minus 2 times negative 3, this negative 2 times this negative 3. And so I know for many that's kind of an unsatisfactory explanation, because it's just using numbers and reasoning and the ideas we have about, what we already know in mathematics. We know that, right, our first statement, 2 times 3 minus, take away, 2 times 3, right here, right? If you have a positive and you then subtract the same thing, right? That's 0. Well, then we know that, well, subtracting 2 times 3 is the same as, right, adding 2 times a negative 3. Or again, you can do it with this way, the negative 2 times the positive 3. Either way you write it, it's the same outcome. I just wanted to use the negative 3 since we started with the negatives over here. And then, and now we just use what we know about equations, right? If this is, if this is adding, then we take away, right, this whole term from both sides, right? What we do to one side, we do to the other side. And then 0 plus anything, right? 0 is the additive identity. So this stays exactly the same. And so this has to equal that. And therefore, right, 6 equals 6. So this negative 2, right, if we even want to say it, so 6 equals positive 6 equals this negative 2 times the negative 3. And so I know that's not a nice, succinct, clean, clear explanation, but I wanted to give you the rationale for why this is true. You can do this with any numbers. You can do this with A's and B's if you want to do it for the general case, or any letters for the general case. And I would encourage you to do so. See if you can take that same logical, deductive reasoning. And this is the way, mathematicians prove stuff. So you are being a mathematician, and this is a type of a proof by, if we used A's and B's, right? Proof, that would be a proof.